The last lecture, I ended my lecture saying that there are a couple of theorems for moment of inertia. We'll be discussing them now. They are known as parallel axis theorem and perpendicular axis theorem. First, let us just see what a parallel axis is, what a perpendicular axis is. Now I have an object. Suppose I tell you, bring me this object to the hole so that I can rotate it. You will naturally put the hole in the center of the object. So suppose I put a hole somewhere, let's say here, somewhere here, away from the center. Then I have an axis which is parallel to the original axis. The original axis would have gone like this. Now my new axis goes like this, right? Goes like this. It is parallel to the original axis. Parallel axis theorem. That's it. Perpendicular axis theorem is applicable only for two-dimensional objects. So I have an object. I have a moment of inertia through this axis. I have a moment of inertia through this axis. Now, based on this, if I have a third axis, which goes like this, mind you, I keep telling it's a two-dimensional object, not a three-dimensional object. I have a fresh axis, which is going like this, which is parallel to this axis as well as this axis. Then I speak about perpendicular axis theorem. Now, let us go into discussing this parallel axis and perpendicular axis theorem and see what the relationships are. Okay. So we shall be seeing today theorems of moment of inertia. Theorems of moment of inertia. So the first thing we are going to see is parallel axis theorem. So let me say I have an object like this. It can be a regular object or an irregular object, but I am considering a regular object because it's easy to find the center. That's why. Okay, so I'm just taking an axis, an object like this, and I'm considering an axis to go through this, the center. This will be the center. Sorry, this is not exactly the center. Please assume that this is the center, right? So let me say this axis, I call this axis as x dash at a distance r. So I can say the moment of inertia when I have the axis like this, ix dash is equal to m r square. We saw this relationship in the last lecture. Now I am taking another axis. Let me say I'm calling it a dash at a distance x from the original axis. This is at a distance x from the original axis. So my new moment of inertia a dash will be equal to m r plus x the whole square. Or you could write it as m r square plus m x square plus 2m r x. I could write this as r square sigma m because r is fixed, sigma m x square plus, I will bring this r outside, 2r sigma mx. Now look at this relationship mx. Now when I say this sigma, I can put an I here as well. I can put this I subscript as well everywhere, right? And I can say each of the moment of inertia of each of the particle. And when you speak about moment of inertia of each of the particle, they actually cancel out each other because, you know, moment of inertia always the moment of inertia will act in such a way that it resists rotation, I told you. So this particular term will turn out to be 0. And here instead of this, I will substitute a capital M. So my a dash, my new axis, moment of inertia through my new axis, I can give it as m r square plus sigma mi xi square. That is moment of inertia taken through the center plus moment of inertia of the axis considering the distance from the central axis. This is parallel axis theorem. Next we will see perpendicular axis theorem. Again, I told you for perpendicular axis theorem, I must always consider a planar body. a two-dimensional body. I have an x-axis and a y-axis. Okay, I have these two axes, and I have this object here. Okay, or let me take it even. Okay, I'll have it here. So this has coordinates xi and yi. Okay, this is my x-axis and this is my y-axis. Now I shall write ixx. Okay, so here from x-axis, this is at a distance of ya. Am I right? So ixx will be equal to mi yi square. Similarly, from y-axis, this is actually at a distance of xi. So I can say iyy is equal to mi xi square. So now I'm going to have a third axis passing like this, okay, passing like this, and here the coordinate is Ra. So I can say now Izz is equal to mi Ra square. But now look at this, I can say Ra is equal to, Ra square is equal to xi square plus yi square. So I can say Izz is equal to mi xi square plus yi square, or I can say Izz is equal to mi xi square plus mi yi square, or you can say Izz is equal to, what is mi xi square? Iyy plus, what is mi yi square? Ixx. So the perpendicular axis theorem states that the perpendicular axis to the plane, the moment of inertia of that is equal to moment of inertia through one plane and through one axis plus the moment of inertia through the other axis. This is perpendicular axis theorem, right? So based on these theorems, we'll see how moment of inertia of various objects are calculated in the next lecture.